Dear evil engineer, I am a creature of darkness, by which I mean that I am nocturnal. I suffer from extraordinary light sensitivity, which forces me to restrict my waking hours to between dusk and dawn. This is of great inconvenience to me, particularly in the summer. I resent being unsynchronized with the rest of the world. I live in a town in East Europe, and its nightlife scene consists of some kebab shops, the second nicest gym in town, and a golf-themed bar. Diurnal normativity has caused silent suffering for my kind for many centuries. The rest of the world must be forced to experience this life of darkness. Could you tell me how to put a big pair of sunglasses on the earth so the sun no longer shines on the world? Yours, a vampire.
Dear villain, your letter touches on a controversial subject, solar radiation management. Some argue that it's critical to give serious consideration to drastic geoengineering, given that carbon emissions are not being cut quickly enough to limit warming to 1.5 degrees Celsius. Following COP26, estimates are 2.4 degrees Celsius. Others argue that this would legitimize the idea that there is a Plan B, giving emitters license to slacken their climate efforts. If it does, who cares? Not us. Space-based solar radiation management boils down to putting something between the Earth and the Sun to reduce the amount of sunlight transmitted to Earth. The basic principles were laid down in 1989 by James Early, who suggested a glass disk at a Lagrangian point where gravitational forces of two massive orbiting bodies and the centrifugal force balance. There are 5 for the Earth and Sun. By placing a disk at L1 between the two bodies and 1.5 million kilometers from Earth, the relatively stable disk casts a penumbra that covers the planet. Suggestions for form factor vary, including a large glass lens to disperse light or a mirror to reflect it. Now, by large, we mean extremely large, in the sense of a disk comparable to that of a moon or planet, in order to block the less than 2% of sunlight reaching Earth. The figure usually given as sufficient for counteracting global warming is 1.8%. This presents some obvious questions. Is it possible to construct something so large? Is it possible to launch it? And what can it be made from? Early suggested a chunk of moon or asteroid. Okay, say you captured an asteroid and start beating it down into a disk. The next issue to resolve is that of solar radiation pressure, which will cause the disk to move out of place. Radiation pressure is greater for reflective objects. Reflectivity can be reduced somewhat by applying a coating that absorbs light energy on the sunward side and re-emits it as thermal energy on the other. However, better than absorbing and reflecting light would be to refract it with a giant lens, deflecting enough to miss Earth but not enough to transfer significant radiation pressure. According to astronomer Roger Angel, who looked into the feasibility of a sunshade in a 2006 science paper, the ideal lens would have a 6 million square kilometre surface area and orbit at 2.2 million kilometres from Earth. Well, I expect not even the world's keenest lens collector has a lens that big. But if any readers have a spare one in the garage and may be willing to help my correspondent, please write and I shall put you in contact. A 2015 paper on the subject proposed a configuration involving a pair of smaller discs. That sounds more like sunglasses, doesn't it? Unfortunately, these would still involve an unprecedented challenge to manufacture and launch. So, we need to go smaller. Angel suggested much smaller, and many, many more of them. 16 trillion very thin lenses, 0.06 meters in diameter, each weighing just 1 gram. These could be launched in stacks of approximately 1 million over 20 years for $130 billion in 2006 money, he estimated. Still, we must consider the natural instability of orbiting at L1. It is an unstable equilibrium, easily disturbed by factors such as the Moon's gravity, and the orbit will naturally decay in a matter of years. Equipping them to propel themselves back into position is preferable to replacing them or sending up satellites to adjust them, given the sheer number of lenses required. Angel suggests that this would not require heavy, expendable propellant. Instead, he suggests harnessing solar radiation pressure with rotating mirrors, controlled by spacecraft scattered throughout the cloud of lenses in a GPS-like system pinging the lenses. The scale of the project would be comparable to the largest civil engineering projects, such as the Three Gorges Dam, and would likely take decades and trillions of dollars. However, Angel concluded, and other scientists have concurred, that there is no technical reason why this could not be implemented. Developments since his 2006 analysis, such as demonstrations of reusable rockets, render it a closer possibility. All this is very well if it comes to planning for an Earth rendered delightfully uninhabitable by our valued partners in the fossil fuel industry. But how well does it suit your query? Well, a cloud of 16 trillion lenses is not a pair of sunglasses, unless perhaps you are an elder one. Are you an elder one? Aside from the obvious, sunglasses protect the eyes through polarization, reflection, and absorption, while these lenses act more like prescription glasses, refracting sunlight. More to the point, the solution outlined here would reduce the amount of sunlight falling on Earth by just 1.8%, which is not quite the plunging the world into darkness you may have envisioned. You'd better get started soon. You have hundreds of trillions of lenses to manufacture and launch. Hopefully, you are immortal as well as nocturnal. Yours, the evil engineer.